the objective of this video is to apply the work energy theorem to determine the change in an object's kinetic energy and speed that results from the application of specified forces, or to determine the force that is required in order to bring an object to rest for a specific distance. This is one of your College Board AP objectives. Alright, so an example problem would be if we took the speed of a car and we increased it by 50%, then by what factor are we changing the minimum braking distance required for it to stop? Well, the work energy theorem says that work net is going to equal change in kinetic energy, which would then just be also represented by KE final minus kinetic energy initial. Well, in this case, kinetic energy final is always going to be 0 if we're talking about going to a stop, so the work done by friction is going to be a negative value. We're losing energy. Okay, so let's take the first case. So work, as we know, it equals force times displacement times cosine of theta between them, but the angle between the applied force and the direction that we're doing work is the same, so the cosine of that angle is going to be 1. Now, we'll call it the first point where we don't have a change in kinetic energy, the original speed, that's just going to be negative KE1, we'll call it. And KE1 is going to be 1/2 mv squared. Now let's compare that to another amount of work. We'll call it work 2. The work required to stop a car that's going 1.5 times as fast. So that's going to be equal to negative KE2, where KE2 is the kinetic energy at the speed of 1.5 times the original speed. So I'm going to put 1.5 v here in the square root, or sorry, in the square. And so if I compare the amount of work it takes to stop, if I compare work 2 to work 1, then I can get a ratio of distance 1 to distance 2. So let's divide these two out. I get, if I divide both lines, I get d1 divided by d2 is going to basically equal 1 over 1.5 squared. And therefore, d2 equals 1.5 squared times distance 1, or 2.25 distance 1. Okay, let's see if you can try an example like that. So you can pause the video and go to the next problem, try it, and press play when you're ready to check your work.